The first question most people ask us is why hydro? Access to electricity in Uganda on a national level is around 15%, but in rural areas it is only 7%. The Ugandan government is slowly but surely connecting towns and villages to the national grid, but the rural communities we work in are so remote they are highly unlikely to be connected to the grid any time in the near future. Also, the electricity from the grid is very expensive compared to what the residents of Bihondo and Mabwe pay for theirs. The majority of the Bihondo and Mabwe residents are farmers and receive very low incomes, so our low-cost solutions suit them much better.
Pico Hydro is the best green energy generation option for these communities due to the rainy climate,
just a small rain,
the mountainous environment, and the relatively low upfront and maintenance costs. Appropriate technology is vital for the sustainability of these schemes, because our ultimate goal is that the schemes are totally self-sufficient, with the local residents carrying out all reparations, which are paid for by residents' monthly bills.
In the villages that we work, residents volunteer to be on a local committee who overlook the maintenance and expansion of the scheme and ensure that the scheme is fair and is on track to be financially sustainable. Technicians are part of the committee. Their roles include repairing pipes, poles, wiring and implementing new lines to connect those who want power. Technicians receive wages for their work and are an invaluable asset to the community, as they often act as the bridge between us and the residents. In Bihondo, the 2015 team set about increasing the scheme's power output, an objective laid out and initiated by previous teams. By building a steel-reinforced concrete channel to replace the damaged pipes and wooden dam already in place, the flow rate was increased. A new powerhouse, which contains the turbine and alternator, was also completed, meaning that the energy coming from the increased flow rate can be harnessed more efficiently. We aim to synchronise a further alternator to the system next year to boost the power output as the scheme continues to grow.
The committee in Bihondo expressed some issues of monitoring how many light bulbs each house used, so we need to find a way to control this. We spent a few days testing 2 different types of load limiters, whose resistance increased exponentially once a certain amount of current had been drawn. We then designed different combinations of the load limiters, depending on how many light bulbs the house wanted and how far away they were from the source. A pricing plan was then made, with discussion and research from the committee, so that the scheme could become more self-sufficient, carry out any repairs and still have money left over to improve the scheme elsewhere.
An ideal collaboration leaves villages with power, allows payments to the committee to be reinvested into the scheme, and keeps technicians busy with expanding the scheme.
Damn.
The Mount Gessi scheme was built to provide electricity to a school located in the Rwenzori Mountains, approximately 10 kilometres outside of Fort Portal in western Uganda. The scheme, which serves the Nyakatikoli community, provides electricity to a school with around 90 students and sits 100 metres downhill from the school buildings. The scheme was first installed in 2010 when the team built a wooden flow channel. Unfortunately, the wood rotted quite quickly after it was first installed as it was in constant contact with the stream water. The 2012 team repaired the wooden channel by replacing sections of it with new timber. However, the scheme was not maintained sufficiently by the local community. As a result, the turbine, specifically the runner, became clogged with sand and debris from the stream. This led to increased wear on the runner and the eventual failure of the turbine. In 2014, the team installed a reinforced concrete channel to replace the old wooden one. In 2015, with the civil works completed, the team built a new timber powerhouse made from locally sourced hardwood. The axial turbine was installed. The team then focused on the power transmission grid. 6 bush poles were erected to conduct generated electricity from the powerhouse to the school buildings. Reinforced concrete godfathers were also made to increase the durability of the poles. Inside the school buildings, light bulb fittings, plug sockets and pull switches were installed. The scheme currently generates 500 watts of power. enough for light fittings in all of the school buildings as well as exterior security lighting. The team hopes that the electricity generated by the scheme will allow the children to study for longer periods of time using electric lighting, thereby boosting their grades and significantly improving the quality of their education.
I think the future is going to be good, since the power is going to be expanded.
In the future, we hope every homestead in this village will be having power until life will be moving smoothly.